and welcome to Tidbit topic number 3.
Chris and I met at the mall to do some brainstorming, and we couldn't help but notice that it seemed like every other person was sneezing or sniffling or hacking up a lung. Half to myself and half out loud, I mumbled, "Wonder how many people still follow the maxim, feed a cold and starve a fever."
I don't know what that means.
I can't believe that you don't know. Something else we have to discuss.
That's another thing.
Just one more thing added to the list.
And that is how we came up with today's Tidbit topic, number 3. Feed a cold, starve a fever. Is there any science behind this?
Turns out the answer's not so straightforward. But new never is, right?
Never is.
Never is. But new and exciting information is beginning to emerge and suggests that feeding a cold and feeding a fever is better advice. So let's start at the beginning. The phrase, fasting is a great remedy for fever, can be traced to a dictionary written by the schoolmaster and lexicographer John Withels in 1574, according to a 2014 Scientific American article. The belief was that feeding a cold would warm the body and therefore facilitate healing, while starving a fever would cool the body down. Fever is a part of the immune system's attempt to beat intruders by creating a somewhat hostile environment. However, raising body temperature boosts metabolism, which results in increased need for calories. And fever can cause dehydration through perspiration. Dehydration dries up mucus, making it more difficult for the body to rid itself of intruders. It seems well established that fluids are essential to recovery. Well, what about chicken soup? Is it the panacea grandmas have touted for generations? It turns out chicken soup is not a cure, but the fluid is obviously good for us, and so is the steam, and so are the calories. And the chicken in the chicken soup also supplies an amino acid known as cysteine that can help thin mucus. It's similar to a drug that we use in medicine called acetylcysteine, which is prescribed to some people who have chronic bronchitis or cystic fibrosis. Now, here's where things begin to deviate from conventional thought. The concept of nutritional regulation and its role in treating illness is a comparatively new field of scientific endeavor, and if proven effective, has tremendous implications for treating illness in the future. This field of study is especially relevant since antibiotic resistance and the development of superbugs, bacteria resistant to antibiotics, are estimated to be responsible for more than 2 million infections annually in the United States and for more than 20,000 deaths per year. An alternative or adjunct method of therapy would therefore be more than welcome to the doctor's armamentarium. We now know that eating healthy foods during illness, even when we don't feel like it, helps generate energy required for healing. And based on studies in mice, it appears that different infections require different nutritional interventions. That would intuitively make sense. In effect, the counterattack by the body needs to be tailored to the mechanism of attack. You can make the analogy between a tennis, boxing, or MMA match where styles of the competitors determine strategy. In 2002, a study published in the journal Clinical and Diagnostic Laboratory Immunology, that's a mouthful, suggested that nutritional status has a bona fide effect on the regulation of the immune response. Dr. Ruslan Medzhakov and his team at Yale University performed a series of experiments with mice infected either with the influenza virus or a type of bacteria called Listeria. Their findings were published in Cell in 2016. They found that the flu-infected mice reduced their food intake. However, when the researchers augmented the caloric intake of some of the sick mice, their odds of survival were significantly better than those who weren't given the extra nutrition. The animal's survival appeared to hinge on the availability of sugar, known as glucose. These researchers found the exact opposite occurred when the bacteria Listeria was used to cause the illness. The Yale team also used PET scans in their study. PET scans are used by doctors to determine how tissues and organs function. Medsitov and his co-workers PET-scanned mice suffering from viral infections and bacterial infections and demonstrated significant differences in the way the brains of the mice infected with the different organisms use glucose, the brain's primary energy source. Further groundbreaking work was done at the Salk Institute by Janelle Ayers and Sheila Rao and published in the prestigious journal Cell in 2017. Until that time, we had little to no understanding as to the intricacies of the chess game between host and bacterial invader. The two researchers infected mice with a particular species of Salmonella, a type of bacteria that can cause food poisoning in humans. What they discovered was that increasing healthy food intake caused the sick mice to survive longer or recover, which turned out surprisingly to also be advantageous to the bacteria. They discovered that mice who ate more prevented the organisms from leaving the gut, and this may seem counterintuitive. But it is currently hypothesized that the spread of bacteria to other parts of the body is due to their search for more nutrition. If the host is better fed, then there is no need for them to spread and wander. You can think of it as analogous to animals in the wild whose habitats have been changed due to human interference. They will wander out of their usual domains in search of nutrition. The trade-off for the bacteria is that they become less virulent. That is, they are less toxic to that individual host, but they gain in that they become more transmissible. That is, their chance of spread to other hosts becomes greater the longer the original host survives. And it turns out that the invaders have mechanisms to hack our gut-brain biofeedback loop, the one we discussed in Tidbit 2, You Are What You Eat. It turns out that the bacteria used by Rao and Ayers in their research study make a substance that turns off our natural desire to stop eating when we're sick, boosting the chance of the bacteria to have greater transmissibility. Taken together, these findings suggest that one day we may be able to help people mount successful responses to different types of infections without the use or by minimizing the use of antibiotics. This research is in its infancy, but seems to hold some promising therapeutic possibilities for the future. For now, it is recommended that you follow the advice of your healthcare provider, take antibiotics if prescribed, eat nutrient-rich foods, and stay hydrated when ill. Until next time, this is Dr. Sherry reminding you to live each day with passion, compassion, and introspection.
This has been Tidbit topic number 3. Thank you everybody for watching.
Thanks for listening.